Alright, good day everyone. So welcome back to my YouTube channel, and it's Kasaligan Vlogs, and we're going to talk about analytic geometry, the topic all about division of line segment. So watch and learn, and please be mindful of everything that I will be talking about today. So let's have first the theorem. If point 1 x sub 1 and y sub 1 and point 2 x sub 2 y sub 2 are any two points in R squared, which is the distance, then the coordinates of the point PO x sub O y sub O that divides the segment P1 P2 in the ratio R is equal to P1 PO over P1 P2, which R is an element of R, are given by this formula for division of line segment. So take note, this is the formula for division of line segment. But how did we come up with this formula of the line segment? So what's the concept behind this? So let us have first the point here. So if we're going to illustrate, okay, so if we're going to illustrate here, if this is the point 1 here, which is x sub 1 based on the definition, and this is point 2 x sub 2 and y sub 2. If this is the point here going up here, then the coordinates of the point that divides the segment P1 is the ratio of P1 PO. So let us assume this is between, this is our PO, and this is our x sub 0 and y sub 0. So in this case, we have to find the ratio, the distance between, because we have now the longer lines and this is another line here. Okay, so there are two lines here, and we can now form into proportions, or the ratio between the two lines. So take note, the ratio if this one is, we have the ratio is equal to the smaller, which is P1 to PO over, right, to get the ratio. So P1 and PO, and this is P1 and P2. So smaller line and bigger line here. So that's the how to get R is equal to PO over P1 and P2. So let us have first in terms of x. So in terms of x, we need to get the distance of this one to get the ratio. So we have here in terms of x, which is this is x and this is x. So we have here x sub O minus x sub 1 over the ratio again here, which is x sub 2 minus x sub 1. You get a point here? Let's go back. So this is line 1 and this is line 2. So first is in terms of x, our line 1 is x sub O minus x sub 1 because this is the smaller line. And this is x sub 2, bigger line, minus x sub 1 is equal to R. So cross multiply, x sub O minus x sub 1 is equal to R times x sub 2 minus x sub 1. So therefore x sub O is equal to x sub 1 positive plus R x sub 2 minus x sub 1. So this R is, shall we say, this is the ratio between. Alright, so in terms of y, so we have here the formula now. In terms of y, so we have here y sub O minus y sub 1, right? Over y sub 2 minus y sub 1 is equal to R. Cross multiply, y sub O minus y sub 1 is equal to R, y sub 2 minus y sub 1. So now, our y sub O is equal to y sub 1 plus R times y sub 2 minus y sub 1. So now this is the second equation. So we have here y sub o is equal to y sub 1 in order for us to get for y sub o and x sub o. So take note, the ratio that we're going to refer is this one. So we'll make use of this ratio along with the topic division of line segment. Take note, the ratio is R is equal to P1 PO over P1 P2. So there are cases that we need to understand here. So first is cases for division of line segment. If PO lies between P1 and P2, then the ratio should be between 0 and 1. So it should be fraction, but at positive between 0 to 1. It means in case number 1, it looks like this. If it is a graph, this is point 1 and this is our point 2. So if this is x sub 1, y sub 1, and x sub 2 minus x sub 2, y sub 2, the point is between here. So P, O, x sub O, y sub O. So therefore the ratio is greater than 0 but lesser than 1. So it could be our ratio is in a fraction like 1/4, right? That's an example. So the ratio should be between 0 to 1. In case number 2, if the ratio, if PO lies in the extension of P1 to P2 and through P2, then R is greater than 1. So if they extended through P2, so therefore R is greater than 1. Let us have first this one illustration or case number 2. So this is our P1, x sub 1, y sub 1. And this is our point 2, x sub 2, y sub 2. So if this is a point here, going here, and being extended here, going to PO. So there's x sub O and y sub O. So the extension is beyond P2. So therefore, RR is greater than 1. So it could be our ratio is equal to 2 and up. So that is greater than 1. So the case 2 is extended beyond P2. In case number 3, so in case number 3, so we have here the graph. So P1, x sub 1, y sub 1, and this is our P2, x sub 2, y sub 2. So if this is a point here, so extended through P1, here the extension is beyond here. So therefore x sub O, y sub O. So R is lesser than 0. So it could be R is negative 1/4 or negative 3/4, as long as this is a negative R when it's extended beyond P1. Again, there are 3 cases that we need to remember. If case 1, between PO, P1 to P2, so therefore R is between 0 to 1. In case number 2, when R is greater than 1, so therefore we could say that R is greater than 2. It could be 2 up greater than 1, or we have not 2 up, we have 1 point something up, right? So case number 3 is R is extended. The ratio is extended from P1. So the extension is in the P1, not in the P2. So therefore, R is a negative less than 0. So take note of these cases. So we have here the corollary. If point xy is the midpoint of the segment P1, x sub 1, y sub 1, P2, and x sub 2, y sub 2, then this is now the midpoint formula. Alright, so this is the midpoint formula that very familiar when I was in high school. Okay, so how to derive this midpoint formula? By the use of the division of line segment x sub O, x sub 1 plus R times x sub 2 minus x sub 1. Since this is the midpoint, what's the difference between and the midpoint? If this is here A and B, so the midpoint is this one, half of this one. If this is 1 and this is 1. What is between A to B? Meaning to say, between, we could have this one here, between. So the ratio of this one, depending, based on the illustration, A is greater than B. So therefore, the ratio, there is a ratio which is not equal when we talk about between. But the ratio is equal, so therefore, in between the midpoint of this A and B, so therefore, this is the ratio are equal here. The distance are equal here rather. So therefore, if that is equal, by the use of R is equal to P1, PO, if this is our P1 and this is our P2 and this is our PO, so therefore P1, P2, our P1 to PO is equal to 1 over P1 to P2, that is 1 plus 1, that is 2. So therefore, our R in the midpoint is 1/2. So X sub O is equal to X sub 1 plus 1/2 X sub 2 minus X sub 1. So we have to combine here. X sub O is equal to X sub 1 plus X sub 2 minus, over 2 rather, X sub 2 minus X sub 1. So we have X sub O is equal to LCD. We have 2. So 2X sub 1 plus X sub 2 minus X sub 1. So cancel is 1 here. And this is 2X sub O is equal to X sub 2 plus X sub 1. So X sub O is equal to X sub 2 plus X sub 1 divided by 2. So this is the midpoint for X sub O. And for Y, same here. Y sub O is equal to Y sub 1 plus R X sub 2 minus X sub 1. So Y sub O is equal to X sub 1, right, Y sub 1 rather, plus 1/2. This is Y rather. Y sub 2 minus Y sub 1. Y sub O is equal to Y sub 1 is equal plus Y sub 2 minus Y sub 1 divided by 2. Take the LCD. Same process. So 2Y sub 1 plus Y sub 2 minus Y sub 1. So cancel 1 here. So 2Y sub O is equal to Y sub 2 plus Y sub 1 over, not over, because that is cross multiply. So Y sub O is equal to Y sub 2 plus Y sub 1 over 2. So this is the formula for midpoint. So that is corollary for the division of line segment when it is divides equally, or the midpoint. Alright, so we have here problem number 1. Find the coordinates of the point that is 2/3 of the way from P1. -2, -1, and P2, 3, and 2. So let's solve. So based on the illustration, okay, we'll have to illustrate. Our P1 is -2 and -1. This is our P1. Our P2 is 3, 2, 3, and 2. Okay, so that is 2/3 of the way from P1. Okay, so since 2/3, that segment is divided into 3. 1, 2, 3. So if this is 2/3, so this is R PO. X sub O, Y sub O. So this is 2/3, so 1, this is 1, this is 1, this is 1. So this is 2 and 3. No, not 3. So 2 here because this one. So the ratio is P1 PO over P1 P2. Let's go back. So 2/3 of the way. So 1, 2, over 3, that is 2/3 of the way. So this is the length between P1 to P2, P1 to PO is 2, and the length of P1 to P2 is 3. So R is equal to P1 to PO, that is 2, over P1 to P2, that is 3. So that is 2/3 of the way. So very easy because we have now the ratio. So by the use of formula here, okay, so let us assume that this is our x sub 1. X sub 1, this is our x sub 1, y sub 1, x sub o, y sub o, and this is x sub 2, y sub 2. X sub o is, x sub 1 is negative 2 plus 2/3 of the way, and x sub 2, which is 3 minus x sub 1, negative 2, it become plus 2. Alright. So x sub o is equal to negative 2 plus 3 plus 2, 5, 10 over 3. So x sub o is equal to, we have to take the LCD. So this is negative 6 plus 10. So this is 4 over 3. So our x sub o is equal to 4 over 3. So now we are now in y sub o is equal to x sub 1 plus r. And this is y sub 1, y sub 2 minus y sub 1. So y sub o is equal to our y sub 1 here is negative 1. Alright, negative 1. Plus the r here is 2/3. Our y sub 2 is 2 here. And y sub 1 is negative 1 plus 1. So y sub o is equal to negative 1 plus 6 over 3. So y sub o, 6 over 3, that is positive 2. So y sub o is equal to 1. So now the point here, x sub o and y sub o, that is 2/3 of the way, is 4/3 and 1. So 4/3 and 1 is the point that is 2/3 of the way from P1, negative 2, negative 1, to P2, 3, and 2. That's it. Let's proceed with problem number 2. The line segment from 1, 4 to 2, 1 is extended a distance equal to twice its length. Find the terminal points. So therefore, there is a directed distance from and to, an extended equal distance to its length. So extended from P, let us have here extended from P2. Okay. 1, 4. Okay, let's have first a graph. 1 and 4. This is our P1 and 2, 1. This is our P2. Is extended equal to a distance equal to twice its length. If this is 1, if this is 1 here, we have to extend 1 and 2. So there is twice its length. So this is our PO. So take note, this is case number 2. If this extended beyond P2, so R is greater than 1. So by the use of the ratio, P1, PO over P1, P2, so our R, what is our R here? If this is 1, and this is 1, and this is 1, so this is equal to 2, twice its length, extended. So P1 to PO, so P1 to PO is equal to 3. P1 to P2, that is equal to 1. So therefore, the ratio is 3. Again, how did they come up with P1 to PO? So this is our P1 going here with PO, which is 1 plus 2. That is equal to 3. And P1 to P2, that is equal to 1 distance only. So therefore, R is equal to 3. By the use of X sub O formula, so therefore X sub O is equal to X sub 1 is 1. This is our X sub 1. Plus the ratio is 3. Our X sub 2 is 2. And X sub 1 that is equal to 1. So X sub O is equal to 1 plus 3 times 1. So X sub O is equal to 1 plus 3. X sub O is equal to 4. Same with the process of Y here. Y sub 2 minus Y sub 1. So Y sub O is equal, or Y sub 1 is 4. This is Y sub 1. The R is 3. Our Y sub 2 is 1 minus our Y sub 1 is 4. So Y sub O is equal to 4 plus 3 times negative 3. So Y sub O is equal to 4 minus 9, that is equal to negative 5. So therefore, our point extended here twice of its equals, extended a distance twice of its length is 4, negative 5. So this, the point PO now is 4, negative 5. Okay, that's it. So take notice, case number 2. Problem number 3. The segment joining P1 2/3 and P2 6/7 is produced beyond P1 to PO to a point PO so that PO is 5 times as from P2 as from P1. Find the coordinates of PO. If we're going to illustrate, okay, the point P1 here, 2, 3, okay, 2, 3, 2 and 3. This is our P1 and 6, 7. One, two, three, four, five, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 6, 7 here. Alright, so we have here the point. So the segment joining P1 and P2 is produced beyond P1. So it is being produced here. So understood, our ratio is lesser than 0. That is point P1 to a point PO. X sub O Y sub O. I don't know what's the point here, but sa extended siya sa P1, where we could have to locate later. So that the point is 5 times as from, okay, so this point here, so that beyond P1 to a point, so that PO is 5 times as from P2 as from P1. So if this is R1 here, so on this 2, this is being extended very much here, here na lang. Okay, let's assume that this is in this part. Okay, too much. So this is 1, and this 2, that this is 1, 2, 3, 4, and 5. It is being cut by 5 times. Because as stated here, if this is our PO, X sub O, Y sub O, the segment joining P1, 2, 3, and 6, 7 is produced beyond P1 here to PO to a point so that PO is 5 times as from P2. So this is PO as from P2, which is from P1. So how to derive, how to say that it is 5 times? Meaning to say that the point of origin, or the point where we could be the basis, is from P1, from this part to here, from P1 as the basis, the distance is 1, and 5 times from this part. These are 5 times. So therefore, our P1 to PO is only 1 unit. And going to PO to P2, that is 5 times, that is 5 units. So therefore, going beyond here. So our R is equal to P1 PO over P1 P2. So our R is P1 PO. So P1 PO, that is equal to 1. And P1 P2, that is equal to how much? That is 4. So since the ruling is R is negative lesser than 0, so therefore understood that is negative 1/4. So now, by the use of our X sub O, X sub 1 plus R times X sub 2 minus X sub 1, our X sub O, our X sub 1 here is 2, right? This is our X sub 1 and Y sub 1. Plus the R is negative 1/4 times our X sub 2 is 6, our X sub 1 is 2. Okay, so X sub O is equal to 2 minus 4 over 4, right? 6, that's 4 over 4. So X sub O is equal to 2 minus 1. Our X sub O is equal to 1. Our Y sub O is Y sub 1 plus R times Y sub 2 minus Y sub 1. So Y sub O, our Y is 3 here. Plus the R is negative 1/4. Okay, plus negative 1/4. This is 3 plus negative 1/4 times Y sub 2 is 7 minus 3. So Y sub O is equal to 3 minus 7 minus 3, that is equal to 4 over 4. So Y sub O is equal to 3 minus 1, Y sub O is equal to 2. So therefore the point here, X sub O is 1 and 2. Okay, the point of X sub O is 1 and 2. So that's 5 times as from P1. Find the coordinates of PO. Next, we have problem number 4. The midpoint of the line segment is 2, negative 1, and the point on the segment is negative 1, negative 3. Find the coordinates of the other endpoints of the segment. So this time, we'll make use of the segment, which is our corollary, which is the midpoint formula. So X sub O is equal to X sub 1 plus X sub 2 over 2. And Y sub O is equal to X sub 1 plus Y sub 1 plus Y sub 2 over 2. So the midpoint is given 2 and negative 1, and the one segment is, the one point is negative 1, negative 3. So let us assume the midpoint of the line segment and the one point to find the coordinates of the other endpoints. Let us assume this is our X sub 1 and Y sub 1. And we're going to find for X sub 2 and Y sub 2. So since X we have here our midpoint is 2, is equal to x sub 1 is negative 1 plus, this is negative 1 rather, plus negative x sub 2, rather wala, x sub 2, wala pala. This is what we're looking for, 2. So 4 is equal to negative 1 plus x sub 2, right? Cross multiply. So we have here 4 plus 1, that is x sub 2. So our x sub 2 is equal to 5. Next, our y sub o is negative 1 is equal y sub 1 is negative 3 plus y sub 2 over 2. So negative 2 is equal to cross multiply negative 3 plus y sub 2. So negative 2 plus 3 is equal to y sub 2. So y sub 2 is equal to 1. So now the other endpoint is 5 and 1. So let's proceed with problem number 5. The segment joining the points P1 negative A3 and P2 negative 4, 1 is extended through P2 so to a point PO, so that P2 is 2/3 of the way from P1 to PO. Find the ratio R, P1 PO over P1 P2 and the coordinates of PO. So let's illustrate first. So P1. Okay, so illustration. Okay, so the first point is 3, negative 8, the other, x in terms of x, negative 8 and 3. This is a point, negative 8 and 3. 8 and 3. Positive, up. Negative 4 and 1. Okay. Okay. It's extended through P2. If this is our P1 and this is our P2, it's extended here. So understood, our R is greater than 1 because the extension is through P2. Okay. Through P2 to a point PO. Through P2 to a point PO, so that P2 is 2/3 of the way. So from P2 to from P1. So 2/3 of the way. So understood, this is 2 and this is 3. From PO, which is x sub O, y sub 1. What is 2/3 of the way? From P, 2/3 of the way from P1 to PO. So meaning to say from P1 to P2 to P1, from here, 2/3 of the way going to PO. So therefore, our R, by getting the ratio P1 PO over, this is 2 and this is 1 because 2/3, when you add 2/3, right? 2 plus 1, the distance of the whole is 3. P1, P2. So R is equal to, what is our P1? Our P1 is P1 to PO, that is equal to 3. And P1 to P2, that is equal to 2. So therefore, the ratio is 3/2. By the use of x sub O plus is equal to x sub 1 plus x sub 2, R rather, minus x sub 1. So x sub O, what is our x sub 1? Negative 8 plus the R is 3/2. X sub 2 is negative 4 minus 8, that is plus 8, right? So we have here x sub O is equal to negative 8 plus 12 over 2. So x of O is equal to negative 8 plus 6. X of O is equal to negative 8 plus 6, that is negative 2. So now this is our x of O. Let's compute with y sub O. Okay, r y sub 2 minus y sub 1. So y sub O is equal to, what is our y sub O? Our y sub O is, y sub 1 is 3 plus the ratio of 3 halves. Our y sub 2 is 1. Our y sub 3. So y sub O is equal to 3 plus 9 over 2. Oh no, not 9, but it's 6. Negative 6 minus, so negative 6 over 2. So y sub O is equal to 3 minus 3. That is equal to y sub O is 0. So the point x sub O is negative 2 and 0. Here, dito pala ang extended form. So this is our point PO. This is now the point which is negative 2 and 0. So the point is negative 2 and 0, which is beyond, extended beyond P2. Okay, so that's all about number 5. Let's proceed with try this. Determine the points of trisection of the line segment joining the points 5.1, 3, negative 2, and 0.296. The segment from P1, negative 1, 2 to point 3, negative 1 extended through P2 to PO, so that the segment P2, PO is equal to twice P1, P2. Find the coordinates of PO. Find the vertices of the triangle if negative 1, 1, 4, negative 1, and negative 2, negative 5 are the midpoints of its sides. Use the concept of our lesson. So take note. So you have to answer it by own. Do not copy, and make sure you have to internalize what is all about division of line segment. So thank you so much. Do not forget to subscribe and share to your classmates and friends out there who has a lesson, have the lessons all about division of line segment. So thank you and God bless everyone. Subscribe, share in your Facebook account. Thank you and God bless.